Hey everyone, if you guys can hear me and see me, can you just drop a short message in the chat? Cool. Okay, thank you. I'm going to start with the presentation. Before that, let me just briefly introduce myself. My name is Akanksha, and I'm a senior data scientist with Shopify. Before that, I've worked as a software engineer with Amazon, and I also worked as a research scientist with Pinrop, which is a fraud detection company. Today, I'm going to talk about anomaly detection and how we can create a product out of this from a data science perspective. We'll briefly cover the introduction, like what anomaly detection is. We'll also go through some of the popular industrial applications for anomaly detection. We'll look at some of the techniques that can help us identify anomalies, and then we will see how we can take this concept into production. Detecting patterns is an important part of how humans learn and make decisions. And hence, human brains are inherently adept at identifying patterns and something that does not fit a pattern. Now, for example, if I show this image to a child, which is an untrained brain, they'll automatically be drawn to the yellow ball. Why? Because it stands out. It does not conform to the white frowning balls. So the next question is, how many balls do I add to the lot that it stops standing out and it forms a new pattern? There is no rigid mathematical rule that can say that it should be 1% of the lot or 10% of the lot. This is going to be a very subjective exercise that will depend on your business use case. Now, moving into some of the applications for anomaly detection. The most widely used is fraud detection. The very popular use cases for this are credit cards, insurance fraud. Then we have identifying the insider trading. And it is a financial anomaly detection, which is very high risk. And it is a very challenging use case because you want the response to be real time so that it can be stopped as soon as there is some fraudulent transaction that has occurred. For example, let's say when you are traveling and you use your credit card, sometimes the transactions get blocked and you might get a message saying that there was some suspicious activity on your card. All these banks and credit card companies, they use fraud detection, which are either developed in-house or they are leveraging third parties. On this slide, I've listed some of the companies. These are the startups that are working in the fraud detection area. Definitely go check them out and look at some of the cool products that they've created in the market. Moving on to some of the other applications, this by means is not an exhaustive list, but these are some of the most useful ones that we see in the market. The first one that I'm going to talk about is intrusion detection that helps us monitor the production traffic to make sure that our network is secure and there's no malware and there's no attack happening by determining the surges and drops in the traffic. The next is manufacturing industries. It is used for predictive maintenance by planning the downtime, by identifying when and where the anomalies have occurred. The most upcoming and the most beneficial to humankind, as I would say, is healthcare sector, where you can identify tumors and, as you can see in this image, identify anomalies in a chest X-ray. In the e-commerce sector, it is used to identify the pricing issues. We'll briefly cover some of the different techniques that can help us identify anomalies. Before we dive into what are the different techniques that can help us identify anomalies, we need to understand which segment we need to use, which segment of algorithms do we need to use to make an anomaly detector. To start with, if you know predefined set of rules that can help you identify what is a normal behavior and separate that from the abnormal behavior, you should go ahead with building a rule-based engine. It is much simpler than building a machine learning model. However, in most of the cases, that is not going to be true. You're going to need a lot of data to train your machine learning algorithm. Now, if you have the label data, you can go ahead with supervised algorithms. In this case, you'll go ahead with the binary classifier where you are going to segregate your anomalies from the normal data. One thing to keep in mind is that anomalies are going to be the rare class. So you will have to look into data balancing techniques and how to train models with the unbalanced data. Again, it is very hard to find clean label data. So you'll have to rely mostly on unsupervised methods to help us identify anomalies. This is the brief outline of some of the popular anomaly detection methods which fall in the unsupervised category. These can be broadly classified into three: distance-based, classification, and reconstruction-based. Now in the distance-based, how does distance help us identify anomalies? If we look at k-means, once we have formed the clusters, the points which are very far away from the centroids are classified as anomalies. In the classification based, let's talk about isolation forest. That is my personal favorite. We divide the data points into nodes based on some rules, which is very similar to random forest. And the isolation forest, we follow a point that can be isolated and then classified according to the distance from the root of the tree. Because the anomalies are going to be the rare events and they're going to be very different from the normal data. So it will be easy to isolate those points from the rest of the data. In the reconstruction based, if we look at autoencoders, these are special kind of neural networks that map the inputs to the outputs. And during the training phase, we feed it only the normal data. So that means during the prediction, and it learns the weights based on that normal data. Now in the prediction phase, if we feed it an abnormal data, it will not be able to reconstruct that with high fidelity, and the reconstruction loss is going to be higher. That's how it helps us identify the anomalies. So far, we have understood what anomaly detection is, what are some of the industrial applications, and also looked at some of the algorithms that can help us identify anomalies. Now we are going to move into a pipeline structure, which can help us take all these concepts into production. This is how a standard data science pipeline looks like. But before we dive into different aspects of the pipeline, which I'm going to cover in the later slides with respect to anomaly detection, I want you to understand that for a data scientist, it's very important to understand the business side of things, the data. Also have a research mindset to be able to engineer features and train machine learning algorithms. And then you also need the software engineering skill sets to be able to automate this pipeline, deploy it in production, and then eventually monitor it. So what are the important things? What are the things that we need to cover in the business intelligence section of the data science pipeline? We need to start with defining what an anomaly is. What is an abnormal behavior for our business use case? For example, if we want to detect fraud in bank transaction over phone, let's say my rule is if a voice of the caller doesn't match at least 95% of the actual owner of the account, I will classify that as an anomaly. We also need to understand the KPIs that are the key performance indicators, because that will help us focus on the larger goal and scope the project. For example, in the credit card fraud, you can identify how much fraud have you prevented. That can be in terms of the dollar value or in terms of number of transactions. Now, once your system identifies what an anomaly is, and it is able to detect that, we need to be able to come up with a plan of action. What does this mean? For example, in case of fraud detection, let's say you identify what a fraud is. What do you want the system to do next? Do we want to just decline the transaction? Do we want to go ahead with the second level of authentication? Or we let them do a smaller transaction? It could be any of these, depending again on your business use case. This section is also a point when you need to decide whether your system is going to be a real-time or is it going to be a batch system. Because this will make the task easier in the later parts of the pipeline, where you can design your system, select the algorithms based on whether it's a real-time or batch system. Now, for real time, for example, in store, credit card transactions, they need to be real time because you need to be able to decide then and there whether this transaction is fraudulent or not. However, if you have an online store, you can keep the transactions up to a day and verify all the transactions that have occurred in the day using a batch system. It is also very important to continuously evaluate and monitor these definitions to keep up to date with the ecosystem and identify the gaps and redo all the steps whenever it's needed. The data and feature engineering, this part starts with identifying all the data sources that can provide you context for your business use case. For example, by just looking at day's data, we see a spike in network traffic. It is going to be an anomaly for that data. However, if you correlate this data with the date and time table and the region, you might identify that maybe it is the peak working hours and it is actually a normal behavior and not an anomaly. So it is very important to identify all the data sources that you can use. The next step is data cleaning. This is even more important for anomaly detection. Why? Because data cleaning helps us remove noise. And noise and anomalies, they have very similar patterns. So we need to be able to distinguish between noise and anomalies so that we do not pollute our predictions with a lot of false positives. Now, when you're working with voice data, you would want to clean it up and extract just the speech part and remove the ambient noise so that when a caller calls from multiple locations, you can still identify them as the same caller and not get lost in the ambient noise. Once you've cleaned the data, you've aggregated, standardized, done all the pre-processing parts, we move on to feature engineering. Here you look at the features that are available in the clean data, but you can also build on them some complex features. For example, velocity. For a transaction data, that could be number of transactions in a day. It is very important that you build and spend a lot of time in feature engineering because your model eventually is going to be only as good as your features. So definitely brainstorm here, spend a lot of time, iterate over it before you finalize your features. Now, coming to the model training part. As we discussed earlier, we can use either supervised or unsupervised methods. For the supervised method, as we know, we need to do train validation split. And in anomaly detection, you have to be very careful about it because anomalies, they are going to be a minority class. For the evaluation, we generally use partial area under the curve, that is PAUC, at our operating points or false positive rates. There's another step in the model training, that is score calibrator. Now, output of the model can sometimes not be directly consumed by the end user. For example, in an isolation forest, the output of a model is the number of splittings required to isolate a point. Now, this will never be between 0 and 1. We need to be able to map this raw splitting data into the new 0 and 1 map. And such that the anomalies, they score higher than our pre-decided threshold for anomalies. So this is an optional but an important part depending on which algorithm you use. Okay, so far we have identified the business questions. We know where our data comes from. We know the feature engineering side of things. We also know how to train the model. But all this is fine for ad hoc, one-time thing. How do we automate this? Before we get into that, I again want to highlight the software engineering skills that are required for this part of the pipeline. At this stage, the one important question to ask is how fast our data evolves, because this will dictate the frequency of our updates to our model. The black dotted box, it will need to be trained as frequent as our data evolves. Now, what do the steps in a deployment pipeline looks like? We can use a cloud service that can be a single host or a cluster to automate the black dotted box, which can be used for data collection, feature engineering, and model training. And this can be done by leveraging job schedulers. Now, once you have trained a predictor and a calibrator, you can wrap them in a Docker before deploying them. Docker is something that is very popular and widely used in the industry. Definitely go look it up if you don't know what Docker is. Now, the deployment of predictor from here will depend on two things. One, whether your system is going to be real time or is it going to be batch. For real time, you need to provide an API such that it can take in a single data point and give you predictions for that single data point. For the batch predictor, you need to be able to expose an API that can take in a file, make predictions on that, and then write that to some cloud place. Now, once you are done with building this system, it is also very important and essential that you build a monitoring system around it. What does the monitoring, performance monitoring looks like for such a system? It comes in two aspects. One is the health of the system. That can be what is the response time of your predictor. You can track that at different percentiles to make sure that your predictor is responding in real time, if it is a real-time system. And the second is evaluation metrics in terms of false positive rate, partial area under the curve. That is going to be decided by your operating point. Once you have identified the metrics that you're going to be monitoring, you need to set up alarms for them. So, and you can also set up alarms in the warning phase so that you get to know when they are entering, when they're going downhill, so that you can fix them before the entire system goes haywire. Now, visualization, this does not fit in any, this is not a sequential part of the data pipeline, but something that assists with every part of the pipeline. And my simple mantra for visualization is, what gives me the most information by spending the least amount of time? Here, if I share the simple example that I'm sharing, if you look at the right bottom side, you see that there is a table, there are a lot of rows. It's very hard to find the anomalous row in that table. But if I translate this into a simple line chart above it, it's very easy to identify the points that are anomalies, how much they vary from the other data, which days did they occur. So it is very important to identify the right visualization for your data. And as I mentioned earlier, it is used for different parts of the pipeline. It can be used for preliminary analysis to understand the data. It is also used for sharing insights with your stakeholders and monitoring the system that we have built. You can build dashboards, reports, and share them with your stakeholders, put alarms on them. You can do a lot more things with visualization. I've also shared some of the companies here that work in the visualization area. They provide you tools for building good visualizations, dashboards, reports, etc. Now, at this point, I would like to share some of the lessons that I've learned during my time in the industry. The first and foremost is it's not a classroom and there's no one size fits all. Picking the right algorithm is going to depend on your business use case and the kind of data you have at hand. The next is BOT. This is very important and something that I really cherish is as a full stack data scientist, the responsibilities, as we saw over the slides, is that it lies from defining the business use case, data collection, exploration, model training, deploying in production, and everything is assisted by visualization. In my personal opinion, it is an area which truly values T-shaped skill set. In short, I would say full stack data scientist is very valuable. Update yourself to update your models. Data science is very dynamic area, and every day there are new papers on new data aspect, engineering, machine learning. Attend conferences, collaborate with people from industry and academia to keep learning. On this note, I would like to thank everyone for attending the presentation, for attending this talk. And if you have any questions, feel free to contact me on LinkedIn, or we can shoot some discussion in the chat section. And yeah, thank you again for attending this talk. Okay, so I guess I don't have any questions for now, but definitely if you have any questions later, you can contact me on my LinkedIn. I have a question. Which method out of reconstruction, distance, and rule-based usually performs the best? It really depends, as I mentioned, on your data. You really need to identify your business use case. There is no standard rule. And that is one of the lessons that I've shared. You need to identify your data and your business use case before you can decide on which of the methods you're going to pick. Cool. Thank you all. Oh, I see another question. How do you assess model performance in unsupervised case of anomaly detection? So you definitely need some kind of data which can be used for evaluation in terms of what are my anomalies. And you depend on metrics like partial area under the curve, that is based on receiving operating characteristic curve. And then you can use a false positive rate, identifying at your operating point that I can accept these many false negatives. What would be my false positive rate at this? So these are some of the metrics that you can use to assess your model performance. How to bring the ground truth? Like I said, it needs some manual effort, but to bring the ground truth for evaluation of the models is not as hard as bringing the ground truth for training the models. Okay, thank you everyone. Have a great rest of your conference. Bye-bye.